All right, we're going to look at how to use the Pythagorean identities to solve a couple problems here on the homework. So find cotangent of theta if cosecant of theta equals 5/4. Okay, so if we remember, I'm going to jot these down real quick. Kind of helpful to know. We have sine squared theta plus cosine squared theta equals 1. We also have 1 plus tangent squared theta equals secant squared. And the third one is 1 plus cotangent squared theta equals cosecant squared theta. All right, so these are the three Pythagorean identities. If you're not sure where these come from, then you need to go back and watch the last video, and that'll tell you, that'll show you how these come from the Pythagorean identity, or the Pythagorean theorem, sorry. All right, so if we have we're looking for cotangent and we have cosecant. All right, so we need to find this and we're given this. Then we need to use this last identity here. Okay, so we're going to say 1 plus cotangent squared of theta is equal to cosecant squared of theta. In this case, cosecant is 5/4. So we got 5/4 squared. Okay? All right, so just like any equation, we're solving for the unknown. Right now, we're looking for cotangent. Okay? So I'm going to go ahead and square my fraction here. So I'm going to have 25/16. And then I have this over here. Now I need to subtract 1. I have positive 1 here. So if I subtract 1, that means the 1's will go away. When I subtract 1 from this side, I need a common denominator. So I'm going to subtract 16/16. 16/16 is just 1. So that gets rid of the 1 there. Okay? And I'm just going to mark this out so it's kind of in our way. So we're going to have cotangent squared of theta is equal to, now we have 25/16 minus 16/16. 25 minus 16 is 9/16. And I'm just going to leave that as a fraction because anything squared, we have to do the square root of that. And if you notice, these are both nice, perfect squares. So to get cotangent, I take the square root of both sides, and I'm going to have the cotangent of theta is equal to the square root of 9 over the square root of 16. So the cotangent of theta is equal to 3/4. Now, do I need a plus minus? No, because we're talking about sides of a triangle, and you can't have a negative side of a triangle. So we're going to leave that as just cotangent of theta is equal to 3/4. Okay? Now, over here, it says find cotangent if tangent is this. So if we look up here, cotangent goes with cosecant, tangent goes with secant, sine and cosine go together. But if you remember, cotangent and tangent are reciprocals of each other. Okay, so if you remember, I'm going to give you just a quick review here. So we have sine of theta equals your opposite over hypotenuse. So your cosecant is the reciprocal of that. Cosecant equals hypotenuse over opposite. So these are inverses of each other. We have cosine of theta is equal to adjacent over hypotenuse. The secant is the reciprocal of the cosine, so hypotenuse over adjacent. And then I have tangent of theta equals opposite over adjacent. And cotangent of theta equals adjacent over opposite. Now, if you look at just this one, and this one, that's where you get the SOHCAHTOA from, okay? And then the others are just the reciprocal of those three. So in the past, you've probably been working with three, the sine, cosine, and tangent functions. Now we've just added the reciprocal functions, which is the cosecant, the secant, and the cotangent. So you should have more details on these and the abbreviations in your notes, okay? But the reason I bring this up, if these two are reciprocals of each other, the hypotenuse is the opposite over adjacent, then the cotangent is the adjacent over the opposite. So to find the cotangent here, we don't have to use these long identities. We can simply say the cotangent of theta is equal to the reciprocal, so it means we flip this. And then we can't leave an irrational number in the denominator, so to get rid of the square root of 14 there, we have to rationalize the denominator by multiplying the top and bottom by the square root of 14. So we're going to have cotangent of theta is equal to 5 times the square root of 14 is just 5 square roots of 14 over the square root squared. The square root of anything squared is just that number. So we got 14 times 2, which is 28. If you can reduce, you should reduce these numbers. 5 and 28 will not reduce. If there's a perfect square in here that needs to be pulled out, you would do that as well. But in this case, that's as far as we can go. So you are finished. Okay? Hopefully this helps a little.